Hi, my name is Jason Clark here at SDSU Extension, and today we're going to talk about the nitrogen cycle. And by talking about the nitrogen cycle, we're hoping that we'll better understand when nitrification inhibitors, as well as urease inhibitors, can help us with managing nitrogen loss and keeping it where the plant can use it. So first of all, let's go ahead and jump in. So we first of all think about in the springtime or the fall time, usually the spring, we're applying that nitrogen fertilizer to that surface of the soil. And then what happens next is important to understand as far as managing nitrogen loss. So we know first of all that urea is on the soil surface, and that urea is going to act with water and a urease enzyme to form ammonium bicarbonate. And that ammonium bicarbonate will then go and act with hydrogen ions to form ammonium, CO2, and water. Now this part depends on the pH of most soils. It's going to happen at different rates. That ammonium is going to interact with hydroxyl groups or OH groups, and it's going to form ammonia gas and water. Now, if that fertilizer is still on the soil surface, that ammonia gas could then be volatilized and lost, and that's not what we want to have happen. So optimal conditions for volatilization losses are one, we're surface applying that urea and we're not incorporating it and it's not getting rained in within a few days or irrigated. There's lots of crop residues, more urease enzyme equals more residue. We have an open crop canopy. There are high temperatures. There's water vapor loss from the surface, such as evaporation. We have a higher pH, and we have low cation exchange capacity that can't hold on to those ammonium ions. So those are the things we're looking at that we have a high chance for loss from urea fertilizers through ammonia volatilization. Now, if we want to reduce that ammonia volatilization, we got to look at this area here. We got to understand that it needs to be incorporated with tillage and or rain to minimize that volatilization, because what happens when that rain comes down and it moves that fertilizer down into the soil, and then when that stops ammonia volatilization, because down here in this ammonia volatilization area, instead of being lost up to the atmosphere, it will react with water, and then it'll move back this way, so it'll form ammonium again once it interacts with water. If it doesn't interact with water on the soil surface up here, that's when we lose that as volatilization. So in order to reduce the volatilization, another thing we can do is use what is called a urease inhibitor. And what that urease inhibitor does is it inhibits or delays this enzyme right here, the urease enzyme, from doing its job of converting urea into ammonium bicarbonate. So if we can lengthen the amount of time that this urea takes to get into ammonium bicarbonate and then go through the rest of the nitrogen cycle, we can increase the amount of time that rain and our tillage events can occur, so we can move that urea into the soil. So when it does go through this process of going to ammonium bicarbonate and ammonium and ammonia gas, that it can actually hit that water, interact with it, and return back to ammonium, which is a more stable form in the soil. So that's what we want to do, is we want to stop that ammonia gas and we want to convert it back to ammonium, and it needs to interact with water in order to do that. So now once we're already in that ammonium form and ammonia form as we see here, there's a few more things that we need to understand about the nitrogen cycle. Since we get to this point, we have interactions with nitrosomonas bacteria that converts that ammonium into nitrite. Then we interact with nitrobacter bacteria that take that nitrate into nitrate. Now, unlike ammonium that's positively charged, nitrate is negatively charged. We also know that the soil colloids are also negatively charged. So there's nothing able to hold on to that because we have two negative charges that actually repel each other. This whole process right here is called nitrification. So the next thing that can happen is if we have this form that we're now in nitrate form. So this is all anaerobic or all aerobic, to this point over here. The next things that can process as far as going in this direction of the cycle need to happen under an anaerobic condition, or we need to be waterlogged or have high precipitation to decrease the amount of oxygen in the soil. And once we have those conditions, that water that's moving down through the soil profile can take that nitrate with it, because the nitrate is negatively charged and it can't hold on to soil particles or the cation exchange capacity. So it can either be moved down in the soil, or if we start getting anaerobic conditions too much, we'll start to go back through the process of going to nitrite, and then we hit these nitric oxide, and also ultimately, if it goes back far enough, it can nitrogen gas. But all these over here can then be lost and serve as potential global warming or other things like that as far as pollution into the atmosphere, as we don't want that cycle to go back up because we want to keep our nitrogen in. So this is called denitrification. So nitrification inhibitors prevent microbes from converting ammonium into nitrate. So they work right here. So we already talked about urease inhibitors. Nitrification inhibitors inhibit these two bacteria right there to keep it in the ammonium form and to stop it from going through nitrification, where we hit this nitrate form that can then be lost through leaching or go back through and be lost through denitrification processes back into the atmosphere. So we looked at these things so far. So inhibitors come in two parts. We either have urease inhibitors that inhibit volatilization or slow down the process, so it takes longer to get there. And we also have nitrification inhibitors that slow down the nitrification process of these bacteria here to help keep it in the ammonium form. Now the big question is, how well do these inhibitors work? Well, hang on and we'll do another quick video here, and you can click on it and you can see how well these inhibitors are working here in South Dakota. Thank you for your time.